Hello everyone, this is Shannon Henry, and today I will be discussing POP3S and SMTPS for ISA 4220 System Security 2 in the fall of 2019. First, we will start with a little bit about how POP3 works. POP3 is the third version of the Post Office Protocol. POP3 is the mail protocol that is used for retrieving emails from an email server. For example, when someone sits down to work for the day and they open their Outlook Express application on their computer, they will use POP3 or a similar protocol to download emails that they have received since they last logged off. The protocol is necessary because an email is not sent straight to a person's computer. For example, say Alice wants to send an email to Bob. She does not send the email directly from her computer to his computer. Instead, the email would be sent from Alice to her internet service provider, who then sends the email to Bob's internet service provider, who holds the email for Bob until Bob can log on to retrieve the email. He would then retrieve it with POP3. Similar to a traditional brick-and-mortar post office, emails are held by the internet service provider until the user is ready to take possession of them. They do not make copies of the emails that are communicated through it, and once the email is downloaded, it will be deleted from the internet service provider unless it's configured otherwise. By default, POP3 will work with most email applications, such as Microsoft Outlook and Eudora. In general, this protocol is great for people who only use one device to check their email, because the email will be stored locally on that device and will be inaccessible from other devices. POP3 works through a TCP connection in 3 different states. The diagram on the right shows how it works. First, it goes through the authorization state. In this state, the server greets the client to indicate that it is ready for commands. The client will provide its credentials to the server to allow access to the mailbox. Next, it's in the transaction state. In this state, the client can perform certain operations in the mailbox, such as retrieving messages and marking retrieved messages for deletion. Finally, it moves on to the update state. The update state occurs when the client is done with its tasks and issues the quit command. The server will delete the messages that the client marked to be deleted, and the session will conclude. There are a few differences between POP3 and POP3S. So POP3S is POP3 over Secure Sockets Layer or Transport Layer Security, which means that data sent this way is encrypted. In comparison, the data sent over POP3 is sent in plain text, which includes email messages and credentials. So this encryption adds an extra layer of protection that most users will want. The encryption process is the same as with HTTPS. It uses an SSL or TLS certificate to verify information and then forms a secure connection once terms are agreed upon, over which information can then be sent securely. POP3 uses port 110, while POP3S uses port 995, which is important information to have for firewall configuration. Since POP3S works on the same encryption protocol as HTTPS does, some of the recommendations for hardening these protocols are the same, but they need to be transferred over to Dovecoat when installing and setting up the POP3 server. The first recommendation is to disable SSL 2.0 and 3.0. These two are not very secure anymore because they're older protocols, therefore they need to be disabled. The same goes for TLS 1.0 and 1.1. They will both need to be disabled as well because they're older protocols that are less secure. It's also good to install an anti-spam method to prevent some amounts of spam from coming into the server. Spam Assassin, RSPAMD, Amavis, and DSpam are all examples of these. Spam Assassin will create spam filtering scores that will be updated automatically with one command. RSpammed is an open source spam filtering option. Amavis is a mail and virus scanner that will check for spam and verify the DKIM, which is a signature on the email that is encrypted with a private key and can be decrypted using the public key in order to verify the authenticity of the sender. Next, we'll move on to SMTP. SMTP is the Simple Mail Transfer Protocol. It is an application layer protocol that is responsible for sending emails. There are 2 important pieces of information in every email address: the user's name and the domain name. The domain name tells the sender's mail server what server it should send the message to, and the user tells the recipient server who this message needs to be delivered to, so it can store it for that person to download using POP3 as we previously discussed. The simple mail transfer protocol has a handshake that is used when it connects to send an email. This is shown in the diagram to the right. In this example, Bob is again trying to send an email to Alice. Bob will send the message to his mail server, who is also the SMTP client in this situation. Bob's mail server will establish a connection over TCP/IP with Alice's mail server. Alice's mail server will return a 220 code to the client. This is when the handshake begins. Bob's server will begin by sending an EHLO command or hello command to Alice's server. In this stage, Bob's server will identify its domain. So say Bob's email address is bob@abc.com. Bob's server will send hello from abc.com. The SMTP server on Alice's side will acknowledge the message by sending a 250 code. The client will send a mail from command with the information about the user attempting to send this message. In this example, it would be mail from bob@abc.com. Again, Alice's server will respond with a 250 code if all has gone as planned so far. Now Bob's server will need to tell Alice's server who the message is supposed to go to. And it does this in the form of a recipient to command. Alice's server, or Alice's email, is alice@xyz.com. So it'll say recipient to alice@xyz.com. Once this is verified that Alice exists on the server, another 250 code will be sent. Now the message transfer can begin. Bob's server will begin this process by sending a data command to Alice's server. In this case, if Alice's server is ready to go, it'll send back a 354 command. This message is then sent from Bob's server to Alice's server one line at a time. Alice's server will know when the message is complete because it will be concluded with a special line at the end of the mail. Once it has received the whole message, it will send Bob's server a 250 code. The final step is to close the established connection between Bob's and Alice's servers. Bob's server will send a quit command to Alice's server, who will respond with a 221 code, and the connection will be ended. That's basically how SMTP works. Similar to POP3S and HTTPS, SMTPS is an SMTP encrypted over SSL or TLS. So information sent this way is encrypted versus being sent in plain text. SMTP is sent over port 25, and SMTPS is sent over 465 or 587, depending on which mail server is used. Here are some hardening recommendations for SMTPS servers on postfix for our Ubuntu 18.04 server and on IIS for our Windows Server 2019. For postfix, we should disable the verify command because while it does prevent some spam, it also allows other people to make educated guesses if an account exists or not. Set the iNet interface to loopback only so that postfix is not attempting to listen on all network interfaces. Unwanted mail relaying can be used by spammers to send their messages and should be prevented. And TLS logging should be enabled so that system administrators can monitor cryptographic exchanges and how they are handled. For the Windows IIS SMTPS server, there should be a limited number of connections allowed. This will prevent a denial of service or DOS attack. There should be a list of blacklisted IP address that is maintained so the system knows not to allow certain mail. Reverse DNS lookup can help prevent spam and spam attacks, so it should be activated. And then spam URL real-time block lists are good to have configured because they can help prevent malware and phishing attacks by filtering out these emails. Here are my works cited, and thanks for watching.